Sorry. Morning all. I'm Zoe. I'll be hosting the first two sessions of today's symposium. And I'd like to introduce today's first session on healthcare systems. And our first speaker is Professor Harold Thimbleby, who is Sea Change Fellow in Digital Health at Swansea University. And he will be talking about healthcare systems. And I'm supposed to say that he's very proud to have authored this book. So Harold, over to you.
Oh, thank you very much, Zoe. I don't know whether you've been watching me and Mike and all the fantastic helpers, but my Apple laptop wouldn't talk to your IPEM video switcher. Zoe said, I've written this book on digital healthcare. One of the things I like doing when I give a talk to a clinical audience, these messes happen all the time, as you know. And I say, thank God a patient is connected to the system. Right? It's Cowboy programming. Something, I don't know where to lay the blame, whether it's Apple and their understanding of HDMI or the little Chinese switching boxes with HDMI going in and out so that it's sent around the country, or I don't know where it is, but there's an HDMI standard and there are Cowboy programmers who mess up and they sit at home and sell stuff. And when you're in an environment like this, you rely on this engineering to work. And like, none of you are going to die if you miss my talk. That's not really a problem. But there are environments where it really matters. And these Cowboy programmers are everywhere. And that's really what I want to say. It's really tempting to tell you everything. But there's a paper about this, which I recommend, especially this quote from Carl Sagan. We've arranged society so that it's really complicated and nobody understands it. It's dangerous, is what Carl Sagan is saying. So what's the story of this talk? There are 3 laws of safety engineering, which I've just invented while I had breakfast. Right? The first one is all engineering is safe until it fails. Right? Next law is competent engineers assure things are safe. And the third law is cowboys don't even worry about whether it's safe or not. They don't even know safety is an issue. Those are my 3 laws of safety engineering. So here's a typical extension lead, and I brought one along with me, which I'm going to play with in a moment. And the thing about extension leads is they work perfectly until they fail. And I have been PAT testing, portable appliance testing, and would you believe about 1/3 of the extension leads I have tested fail? And I took the socket off one extension lead. As you do when you do a PAT test, you do electrical testing and you do visual inspections. And the first thing you do with an extension lead is you dismantle the plugs and sockets and you look at the cable and see if it's damaged. So the first thing I did is I took the cover off the socket on this extension lead, and this is what it was like inside. If you'll allow me to move, I don't know how the cameras work, but the people online can probably see the picture. But for you guys, all I did is I took the cover off the socket. The first thing you spot is there's no earth connection at all. And the other is up here, the cable's cracked and frayed, right? Because people have been yanking it because the cable clamp at the top was loose, which is another failure thing. Some of these things you can sort out. This, it means you've got to replace the lead because you want one with an earth in it. But the key thing is, safety, rules of safety engineering. This extension lead was in use and it works perfectly, right? It works perfectly until it's overloaded or there's an earth fault, and then you're in deep shit. You get electrocuted or you start a fire. Take your pick. You can have a fire and get electrocuted. You can do both at once. But this thing fails a simple PAT test. But what do I say? The lethal engineering is invisible, and the person who wired it up with an inappropriate cable didn't know they were a cowboy, because it's called the Dunning-Kruger effect. They're so incompetent, they don't know they're incompetent. Right? And that is a real socket. Here's the cable to test. First thing you do, have a look in the socket and say, no, I'm failing it. And they say, well, anyway. So I have brought along an extension lead with an RCD, which is just out of touch. And I'm going to show you how you check the RCD. So Oh, wow. So when I copied across the animations from Apple Keynote into Microsoft PowerPoint, change computers, that animation still works. So that's some computing working. So that's an RCD on a to-plug extension lead. And I'm not going to unplug it because time's short, but that's my extension lead. The plug on the other end's got an RCD on it. And I bought, because my PAT tester didn't test RCDs, I bought a Megger RCD tester. These are like 400 quid. It's a serious piece of equipment. And it's full of, well, the message is the physical engineering, electrical engineering, it's really nice. But the programming in it is Cowboy. And there's this sort of funny thing going on. I'm sure Megger are proud of this, and I've corresponded with them, and they think there's nothing wrong with this, and if I don't like it, I can swap it for another one, which will be identical, because they don't understand their programming is Cowboy. And I'm going to demonstrate that, and I hope Zoe will help me show you this is a real RCD tester that you can buy, and you need to be committed to it to pay that much money for one. So this is the story. It's got a programmed feature that is invisible. My suspicion is Megger started making this before the building regulations Part B changed. You're not allowed to do PAT testing or installation testing for that matter if what's called the touch voltage exceeds 50 volts or 25 volts in a wet area like a swimming pool. So this, somebody said, well, we've got this, I'm guessing, they told the programmer, can you sort out the touch voltage regulations? And they said, sure, I'll just change it. And so the changes are invisible and they've got bugs in. It's just Cowboy. So it's got a programmed invisible feature, it's buggy, which I'll demonstrate, and it makes this thing unsafe. It's just unbelievable. There's sort of lovely engineering for the electrical side, and somehow the programmers that Megger employ or outsource to are Cowboys, and they don't know how to do safe programming. This thing, as I said, it's safe until it fails, and I'll show you it failing. So they're digital Cowboys. I've got pictures on here, and I'm going to take Zoe through it, so we'll see what happens. So this is plugged into an extension lead, which I've plugged into the mains just down there. And one of the things you can do on this, you can twiddle this knob to measure the voltage, like, is this safe? So I'm going to switch it on and measure the voltage. Okay, I'm now doing that correctly, and it's about to tell me, is it? Aha, earlier I tested the RCD, which means tripping it. So I've tripped the RCD, I've got to reset the RCD. So that's why this has got a voltmeter on it. I switch the RCD on, and what's the voltage?
237 volts.
So this is telling you this circuit is live, 237 volts. Yes, the hotel. Okay, so that is worth knowing if you're doing some testing. I'm just going to switch it off. And I'm now going to do the secret thing. I'm going to hold down the test button when I switch it on, right? Which nothing on here tells you what that does. And if you wanted to do what I'm about to do, you have no idea how to do it. So I'll switch it on and just wait for it to wake up. Okay, what's the mains voltage?
50.
Okay, did you hear that? This is telling you there, the mains voltage, whoops, is 50 volts, right? This is a lethal error for this device. And this is set at volts, but I happened to switch it on when I held down the test button, which is an invisible feature somebody added after the engineering had been completed. And Cowboy is the polite way of putting it. Right? Somebody could be killed by that. I've got the, here are the pictures, photographs of it. I did this at home. My voltage at home is 245 volts, right? This knob is set at volts. It is measuring the volts down those wires. And if I move it over, this is set at volts. It's measuring the voltage down those wires, and it says 50. This is a lethal error. Yeah, it's Cowboy programming. Even worse, showing 50 volts is unsafe, yeah? Even worse, this is a programmed guess. The touch voltage is actually, I've measured the touch voltage, it's 3 volts at the moment. This is wrong. Right? So it's wrong in 2 levels. One is it's an invisible feature, and the other is the voltage it's claiming as a touch voltage is nonsense. It's a bug. So this is just like extension leads. It seems to work just fine until it kills somebody. Well, the message is this Cowboy software engineering is everywhere. During the pandemic, I decided to buy a coffee machine, as you do, because I miss having proper coffee. And you do homework on coffee machines, and you soon discover, this is my advice to you, if you spend another 50 quid, you can get a better coffee machine. And soon you're up in the thousands, and you discover you spend 100 quid more, you'll get a better one. And you carry on like this. And eventually your wife says you've got to stop and buy the wretched thing. But when you do research on coffee machines, you discover some of them, it's just standard safety engineering. They work perfectly until they blow up. And this is a coffee machine that blew up in the Laughing Duck Canal side in 2020. Those are just photographs I found on the web. So as an engineer, I started thinking, well, I was looking at, the temperature of the water and stuff like that. What's the engineering like? Well, if you go on the web and look for coffee machine fire inside, there are some fantastic photographs, but they're just burnt coffee machines, but like these photographs. But if you look, some people have repaired the coffee machines and you can see what they've discovered. This is a typical domestic coffee machine, and it's crazy engineering, if you ask me. When my son got married, he was given a £1,000 Krups coffee machine, which looks like this inside, and I have repaired it 3 times, right? Because these plastic pipes burst because of the hot water. There are all sorts of reasons why it goes wrong. And not only do they burst, they spray water over live electrics and it starts having fun. But that's a mess. Okay, and as I did my homework, I came across ECM. Have you heard of ECM? Like if you're into coffee, ECM are the bee's knees. This is their website. So far as I can tell, ECM are the only coffee machine manufacturer who shows you the inside of their machines. They're proud of their designs. So this is lovely engineering. And on my laptop, that would have expanded nicely, but it's just sort of done a funny Microsoft transition. So this is what it looks like inside. It's a complete contrast to the ones I showed you earlier. There are 2 chips down here for the PID temperature controller and stuff like that. There are 2 boilers, so there are 2 PIDs, and that's one of the boilers, and it's lovely engineering. And I'm going to turn it over, and that's viewed from the other side. It's lovely on the other side too. And this is what it looks like. It looks very nice, doesn't it? So it's beautiful engineering, and it's well made, and you can see that, and the website advertises it. Same message. Beautiful, in this case, mechanical engineering and Cowboy software engineering. The company want lovely mechanical engineers and designers and people who can polish steel, and they've got that. And goodness knows how they do the programming. Possibly they outsource it to a startup with 2 18-year-olds or something who can't program. They're cowboys. So there's a LCD display that tells you the temperature of the boilers. So can you see that? That says 0.92. Well, it's got 2 boilers, one for steam, one for your coffee. That's actually telling you the right-hand boiler is at 92 centigrade. That's what the decimal point is saying. Right? And the other boiler, coincidentally, when I took these photographs, is also at 92, but the decimal point's in a different place to tell you it's the other boiler. So the steam isn't hot enough. And there's another amusing thing is there are 2 taps on the front. There's the steam and the hot water, and the decimal point is the other way around. So it's not only totally stupid user interface design, but what happens is the engineers said, let's have a 7-segment display. Programmers, I can cope with that. We'll use the decimal point to explain which boiler's which temperature. It gets better. What do you do? It's got a tank inside it, which I've now plumbed in, so this isn't an issue, but it's got a tank inside it, and the tank will run out of water. Okay, programmers, what do you do when you've run out of water? This is what they decided to do. So people who stay in my house, like my daughter and wife, say, Harold, the coffee machine's broken. And I said, no, it's all right. You just need to fill it up with water. So the programmers have to display a state to the user, And the way they decide to do that, well, obviously, if the 7-segment display is off, that's a different state. So this different state means it's run out of water. And there's an even more fun thing. The water tank has got a little level in it that goes up and down. And when the sensor detects it's gone below whatever, it says it's run out of water like this. So I tell my daughter or whatever, well, all you need to do is pull the tank out, put it under the tap and put it back in. Guess what happens? This is another bug, Cowboy engineering. You pull the tank, you lift it up. You got it? What happens? You're also lifting the sensor up. So the sensor goes past the water level thing and the pump comes on and goes, and you can't get the water tank out unless you unplug the coffee machine, right? It's just a little bug that they haven't worked through because the programmers thought this is obvious and they never thought of testing it and discovering that when it's like this, it's switched on with a blank display, which, you know, God knows what it means. You can't get the tank out to fill it up with water because it sucks it back in as soon as you try and lift it up. So it's right? Digital cowboys. They're everywhere. They're in, well, this is safety critical engineering. We need cups of coffee, right? We'll die without them. That's how I spent lockdown, basically. And this is all over the place. You have really good engineers who make physical things, and they do cowboy digital programming. Here's a bigger example. General Electric Aviation make a lovely jet engine. And this is what they say about it. I have to stand to read it because it's too small on the screen. Okay, yeah, I can read it now. This is General Electric's CF34 engine. It helped launch a new era in regional jet aviation. Lots of flight hours and 113 million flight cycles later. It continues to set the standard for performance, durability, and world-class reliability. And they've got all this on their website. It's an amazing piece of physical engineering. Yeah. So GE are good engineers. I'm not questioning that. But I was at a conference and somebody from GE Healthcare, which is a subsidiary of GE, of course, just like GE Aviation is, and they were talking about this amazing perinatal care system they had built, right? And looks amazing. And I was sitting in the front row and I could read this writing. I took a photograph of this slide and I've enlarged it, I hope, with a funny transition. I don't know whether you can read it, but so this is GE who are invited to give a talk at a medical conference, and they're saying they've got this amazing software for perinatal care, and it says, this is not a medical device, it's not intended for diagnosis or treatment decisions. Like, what are they doing? Can you imagine GE turning up to an aviation conference saying, we've got this fantastic engine, right? And they would say that, but actually they're saying the GE CF34 is not an engine, it's not intended for planes or flying, right? You would say they are cowboys, right? This is what is going on in digital all the time. And when I put it like this, it is obvious that the digital software engineering is trying to be polite, it's cowboy. Right? We would not permit this, but we're permitting it with digital stuff everywhere in electrical equipment, in coffee machines, and in perinatal care. And people go out and buy it. So these digital cowboys are everywhere. And I started off saying we've got these laws of engineering. I'll tell you what they are. The 4 laws of safety engineering. 1, all engineering is safe until it fails. Competent engineers assure things stay safe. Digital cowboys don't even think things might be unsafe. And if you've been paying attention, you might notice I've added a law because I started off with 3 laws. These are the 3 laws. The 4th law is we must do better. It's kind of obvious, isn't it? We have got to go out of here and improve the world. There are lots of ways of doing that. For instance, going to the BCS and ending up with qualifications so that the people like Megger can get programs in who have qualifications that show they can program, whereas they're just getting in, I'm guessing, 18-year-olds who think they can program. There are no qualifications for programmers. Right? To do an installation test, you have to have qualifications as an electrician. It's not legal to do an installation test without those qualifications. But to program the equipment to do the installation test, you can be a teenager who knows bugger all about electricity. It's just bonkers. We have cowboys everywhere. We must do better. There you go. So, thank you very much for your patience. Thank you very much for your patience over the accidental demonstration of Cowboy software engineering. But have you got any questions? Have I got any time for questions after the delay at the beginning?
Yeah,
so,
we've got some time for questions.
Sorry, I was probably feeling a bit rushed because it took so long to get going. I hope you've enjoyed it.
Do we have any questions in the room? Are there any online? Oh, Mike? Sure.
So I'll just make the observation. I mean, I've felt this, you know, you probably felt this pain for a long time. I've felt this pain for a long time. It just seemed to me that the reason that the physical thing is good is because people who manage companies can look at it, and you can look at a piece of metal and you can, like, you know, with your eyes go, this has been machined well, or it's not been machined well. The software is completely invisible. And so even if you don't know anything about mechanical engineering, you can look at something and go, that looks quality, or it doesn't look quality. If you don't know anything about software, and the only way you can know whether the software is any good really is to start looking at the source code. It's way beyond most managers, you know, ability or interest. I think that's why it's sort of arisen, you know, because you can't see it. If you could make it visible, people go, oh, that's not acceptable.
Yeah, absolutely. I think another aspect is the CEO or whatever will get a demonstration of the latest product. Let me demonstrate this to you. Oh, just switch it on again. And I'm in front of the CEO, and we've built this Fred, whatever he's called. And I'll show you how it works. And if I kneel down while I do this, you'll hear the RCD trip. Okay, so I'll press the button called test, and I think you might be able to hear it click when it tests it. See? Did you hear it? Yeah. So it has just run 10 milliamps, 20 milliamps, and 30 milliamps, and so on until it tripped. And it tells me it took 27 milliseconds to trip. And the CEO says, ship it. But the software isn't finished. Yeah, because it's invisible, and the programmers think it works, or the CEO thinks it works, so they ship it without doing any quality assurance on the software. One company I visited, I met, they sell infusion pumps, which you might, if you go to hospital, you might be connected to an infusion pump giving you drugs. They sell infusion pumps, they make infusion pumps. I met their programmer. They have one programmer. And I mean, what do you do when you, so I said, well, how do you do code review? And he said, what's that? And I explained what code review was in simple terms. You know what code review is, I don't need to tell you, but I explained what code review was. Do you know what he said? I'm the only programmer, so I don't need to do it. Right? So they make lovely engineered devices just like this, but it's Cowboy software. Somebody just there.
Hi, James Inge. How much of it do you think is down to the coding, the coders being cowboys, and how much down to the engineers who specify what the software is supposed to do, or perhaps don't specify what it's supposed to do?
I think it's both. The instructions to the cowboys, however that happens, is Cowboy itself. And the coders don't know about it coding. And in an ideal world, if the people who specified what they want told some software engineers, the software engineers would say, this is a rather vague specification, can we sort it out and improve it? And you'd have an iterative cycle, and you'd end up with and even better software engineers would say, well, okay, that's fine. Let's also test the user interface and see whether it works in an ecological setting. Like this meter probably works fine, but when you give it to somebody who's forgotten how it works, and they're in the back of a, in the cellar of a church with all these wires everywhere, they can't remember that to change its touch voltage setting, you've got to remember to tis this and press that, because it doesn't tell you. So in a real situation, that is unusable because you're under pressure.
Yvonne Oakeshott Leonardo, is the next step to doing better, do you think, regulation, or have you got some other ideas?
The perfect world is 30 years away. So there's a world where there's sensible regulation and there is competent, certified software engineers. But it's going to take a while to get there because most of the world isn't there at all. I think we should set up teams of competent software engineers who are available to advise on people who start to realize they need a bit of help. At the moment, people don't realize they need help. And if they ask for software engineering help, it's not available. So an example of that, which makes it much more poignant, is, you know, the Post Office Horizon case, arguably the largest miscarriage of justice ever. Something like 750 people were prosecuted because they were alleged to have embezzled lots of money. Right? And some of them committed suicide, some of them got divorced, all sorts of horrific things. It was all down to bugs in the software system that created the fantasy that they had embezzled money. In one case, Seema Misra was prosecuted, she went to prison. In her case, she asked, can I see the computer evidence? And the judge ruled the computer evidence is correct, you don't need to see it. Okay. The common law presumption in Britain from the Criminal Justice Act 2013 is, it is presumed that computer evidence is correct. You're wasting the court's time if you question it. And Seema Misra was not allowed to see the computer evidence against her. I would set up these ideas of software engineering tribunals for all sorts of things, and I would change the law tomorrow that says you can call on the software engineering tribunal to say whether you need to see the relevant documents. And furthermore, if the tribunal can't get the relevant documents because the post office won't release them, the presumption would be the evidence is false. That would be something that could be sorted out tomorrow, and the software engineering tribunals could be set up with volunteers from this room. There are lots of things we can start doing, but if we just go home and enjoy the shiny coffee machine, it's not going to happen.
Harold, thank you very much. That was a really good talk. Can I also say I'm enjoying your book? It's a very good book. I just kind of see analogies with what Adam Johns was saying yesterday about basically the human is not kind of isolated from the environment. So basically, as you say, in healthcare or other situations, you tend to blame the person. Yeah. And there have been terrible cases in healthcare, whereas in fact the software and the system is actually causing those failures, but they only manifest themselves when people make mistakes. And I just think this is so terrible that we actually are forcing blame onto innocent third parties because the system is so terrible. You know, the design is so terrible. So we've got to do something, haven't we, to have a bigger view of this. We can't just say...
Well, you're absolutely right. One of the sad things is the disciplinary processes in organizations don't understand software either. So, you know, an electrician blows up, I don't know, the example I gave, they're in the basement of the church. Let's say they set fire to the church. Well, he's an incompetent engineer, isn't he? Well, this is incompetent. This is the cause of the problem. Or my book, which is just out of reach, is every chapter's got a nurse who goes to prison or a nurse who commits suicide because they're hounded, or in one case, 73 nurses were disciplined, right? And nobody in the hospital thought to say, well, like 73 nurses all disciplined for the same reason. Maybe there's a common cause. Maybe it's a fucked up computer system. Nobody asked that question. They just said, suspended, suspended, suspended. And then they took 5 of them to court. Under criminal court, and some of them were prosecuted and could have ended up in prison. That's one of the stories in there. And it's because nobody is aware that Cowboy engineering messes things up, kills people.
Morning, Harold. Thanks
Hi.
for that. And thanks for the first use of the word fuck at this conference. That's great.
Can I just say, thank you for saying that. I occasionally accidentally say fucked, and occasionally the audience has said, you shouldn't swear. And I have said, if your wife or husband is killed by cowboy digital stuff, fucked is a very polite way of putting it.
So there is a reason for me pointing this out, and that is we're using language in software engineering world, which doesn't translate very well to the non-software engineering world. And you,
fucked is a technical term.
Exactly,
right.
It is. By saying that as an example of the way in which we give the consequences, we're making a joke about it to an extent, right? But we also use the word bug for what we really mean is you've made a cock up, right? You have done something wrong, and it's not clear, therefore, to the non-software engineering people. It's just a bug. Thanks very much, and we can sort it out. Well, it's not a bug. It's an error. You have made a mistake. You are wrong, and we need to change that language. It's not a cute, cuddly
Absolutely,
thing.
and it's not just a bug. You are incompetent.
Yeah.
You should not have done this. One of the things I got involved with, do you remember during the pandemic, 16,000 patient records disappeared inside a fucked up Excel spreadsheet? And the news was, it's a bug. And my little article in the BMJ says, it doesn't use the word fucked, but it says to use an Excel spreadsheet to manage emailed patient data is incompetent. It's not just a bug, and it's okay because it's just a bug. It's a total incompetence.
So
And you're right.
my point is, I think that when the universities and apprenticeships and everybody's doing the training for people who are doing programming as opposed to software engineering, need to understand that it's not a bug, it's an error. And we need to change that language as part of the training.
Yeah.
So that they know that it's their fault, not something that just randomly happened. And that's the impression that we give. It is something that quite randomly happened. And there's a brilliant paper that's just come out, talks about randomness in software, but that's another story altogether. And it gives that impression that it's just something that doesn't, it's not my fault. And that's why you've got those kind of things that are going on with that device, in my view.
Yeah, thanks.
Can I just, there's one quick comment on the chat, was actually to do with firmware and software. So people often don't even consider firmware as being an issue. It's embedded in the system, they don't see it at all. And yet that can have just as many bugs as software that's uploaded. So yeah, yeah, indeed. Right, I think we need to move on.
Yeah, thank you very much for that, Harold. Great talk, thank you.
Okay.